But, so here we are solving now with the distributive property. So it's like factoring, but then you have to set each of those factors equal to 0 and solve for x. So in this left part of the equation, as you're trying to factor, you look for greatest common factor. Do I have one? And what is it if I do? It is 3x. So divide by 3x, divide by 3x. That 3x is a factor. It is your greatest common factor. So you need to put that out front. 3 divided by 3 simplifies to 1. X squared divided by x gives me what? X minus 27 divided by 3 is 9, and x divided by x simplifies to be 1. Equals 0. Remember, it is equal to 0. So then I set this first factor equal to 0, and I set the second factor equal to 0. And divide by 3, divide by 3. X is equal to 0, or add 9, x is equal to 9. Anybody have that for the first one? Very good. Don't forget, if you're talking about something that is squared, you're going to have two values, okay? Or no real solution. All right, so here we go. Number 2. Again, always looking for greatest common factor. Do I have one here? And what is it? Oh, not 3. Could go higher. Yeah, always start looking at your smallest number and start with what that smallest number is. So it is 6, and it's also 6x, okay? Don't forget to check your variables. 6x is the greatest common factor. It goes out front. So 18 divided by 6 is 3. X squared divided by x is x minus 6x divided by 6x. All of those simplify out to be a 1. So now I've got to set each of these equal to 0. 6x equals 0, divide by 6. So x is equal to 0. And here we have a slightly more difficult one that we've had in the past. 3x minus 1 equals 0. Add 1, add 1. 3x equals 1. Trust the process, though. You know the process. So x is equal to 1/3. Did anybody happen to get that x equals 1/3? All right. Yeah, you've got to trust the process. Even though the problem is slightly more difficult, you know you're setting it equal to 0. Excuse me. And you know you're still solving for x. Okay? All right. Any questions about this one? Okay. File that away and take out the notes. Let's see. Period 1. We left off at example 5. Example 5. So we are solving, we're still looking for x equals, solving a quadratic equation by factoring a difference of squares. My personal favorite. Yes, sir. When are grades due? Grades for, what is it, the first, first, I don't know. They were due, they're not due yesterday, but the cutoff was for yesterday. So everything up through February 9th, the grades will be due 2/13, which is next Tuesday, like all of us as teachers have to have grades in by Tuesday. And then I think they come out on the 14th, which is Wednesday, just in time for parent-teacher conferences on Thursday. If that's something that's important to your parents. Does that make sense? So if something was due by yesterday, say the homework that we graded in class, I will get those grades in over the weekend so it's in there in time for parent-teacher conferences.
Good morning. Those students that are read testing this morning should head to their testing room at this time. Thank you.
You are not on for today, right? Okay. So first one, still factoring. So I look for a GCF. Those garlic cheese fries, the greatest common factor. And do I have one here? Survey says no. That was a weak no. All right, so it already says these are a difference of squares. I have two terms. So once we don't have that and we do see it looks like this, I would rewrite it as x squared minus what number squared gives you that 16? 4. So x squared minus 4 squared equals 0. And then this becomes x plus that 4 and x minus that 4 equals 0. Set each of those individually equal to 0. So x plus 4 equals 0, minus 4 minus 4. X is equal to negative 4. Or x minus 4 equals 0, plus 4 plus 4. X is equal to 4. That is your solution. Those are your roots, your x-intercepts, your solutions, and your zeros. Any question about that? See, I told you this wasn't that bad. All right, let's go to B. 4x squared minus 49. Again, check for a greatest common factor first. So always look at the smallest number. Does 4 divide into 49 evenly? No. How about its factor 2? No, because 49 is not even. So I don't have a GCF here. So I go directly and see, oh yeah, 4 and 49. Oh no, those are perfect squares. This is how I would do it. So I know 4 is a perfect square. I know 4 is 2 squared. And then I have the x squared there, minus what number squared gives you 49? 7 squared equals 0. Now, if you have two entities, values, variables that are squared, you can put them together and say that is quantity 2x squared. Okay, and it's like this squared is going to go for everything inside the parentheses. So that is 2 squared and x squared minus 7 squared equals 0. And then I follow my factoring. Since this is squared minus this is squared, I'm going to say 2x plus 7 times 2x minus 7 equals 0. Set the first factor equal to 0. Set the second factor equal to 0. And solve. So minus 7 minus 7. 2x equals negative 7. Divide by 2, divide by 2. X equals negative 7 halves. Or you could say, if you do it on your calculator, negative 3.5. Or, and now we do the other factor. Plus 7, 2x equals 7 divided by 2 divided by 2. X is equal to positive 7 halves, or x equals 3.5. All right. What are you noticing? When they're difference of squares, the roots are exactly what? Not necessarily decimals. They're exactly opposites, right? Yeah, 4 and negative 4, negative 7 halves, positive 7 halves. They're opposites. Any questions on example 5? All right, turn the page. Writing quadratic functions given the zeros. What's another name for the zeros? Roots. What else? Zeros. What another name? Solutions. And the last one, x-intercept. Okay? So you can write the equation of a quadratic function if you know its zeros. You find the factors. Okay, that's step 1. Find the factors. Determine whether the value of a is positive or negative. And it says assume a is 1 or negative 1 unless otherwise specified. All right. We're already down to the bottom of the half page. So looking at this graph, for example 8, write a quadratic function given the graph. What are my roots or x-intercepts? Negative 2 and 6. Remember, it's always where the graph crosses the x-axis. So negative 2 and 6. Looking at our a value, is it positive 1 or negative 1? And why? How do you know? And how do we know this? Yeah, it's opening upward. Okay, opening up. All right, so here we go with factored form. Let me give you the general formula first. Okay, and then let's see if you can get it. Y is equal to whatever the a value is times x minus root 1 times x minus root 2. That is the generic factored form. Okay? So now let's see if we can do this equation in factored form. Y equals, it's an equation, it's always going to start with y. We said our a value was positive 1. So you can write positive 1, you can write 1, or you can just leave it alone. Okay? As long as it's positive. If it's negative, you have to include the negative. So then this x literally is that same x. It's always x. Okay? Minus your root. So again, this is where that opposite comes in. The root is a negative 2, but in its factor, it is going to be positive 2. Because when you subtract a negative 2, you get plus 2. And the second one is literally x again, as is, minus the second root, which is 6, so that is minus 6. It is a positive 6, but when you write it in factored form, it's going to be the opposite. And there you have it. And same way as you're going backwards. If we were to see this in factored form and you see x plus 2, you should know that its root is the negative 2. Okay? X minus 6 means the root is positive 6. Any questions on that? All right. How much we got? We get through this next page, we're done. So check, write a quadratic function in factored form for the following graphs. I'm going to do the first one with you, and then I'm going to have you do the second one on your own. So really pay attention here. What are my roots or x-intercepts, TJ, for that first problem at the top? 2 and 4. Perfect. Circle them. Make it obvious for yourself. Okay. Fiery, what's my A value here? Positive 1 or negative 1? Positive 1. Excellent. Factored form. Who wants to go for the gusto? What do you think, Jordan? You got for this yet? Y equals positive 1. Uh-huh. Well, what do you guys think? You got it. Woohoo! Yay! Nice job. And you don't need the 1 in front. You can put the positive in front of the 1, or you can just take that 1 out. But that is the factored form. Okay? Any questions about that one? All right, you try the one next to it. Give you a few minutes. Sorry, wasn't trying to snap my gum. And I don't usually chew gum, but I told you, did I tell you I got new crowns? And it feels like I have food in my teeth all the time. And it's not food in my teeth, it's just my teeth. And I'm not used to teeth being there, and they're fat in there, and they're not rounded, and they're sharp. And so I'm like, is that food? And it's not. So I should just go with the fact that it's not food. But it feels so weird. Whew, it's gonna be a warm one today. All right, so let's take a look. What are my roots or x-intercepts here? How about Joel? What are my roots or x-intercepts? And excellent. -2 and +6. Now, I will tell you, I did see on the last test people going like this. Why will I not count -2, 6 again? Yeah, it looks like an ordered pair. It looks like one specific point. So make sure you put the and in, the word and, or something, this little and, however you want to do it with and, okay? My A value, is it +1/2 or -1/2? Negative. And how do we know this? Opening downward. All right, here it is for all the marbles. Factored form. Justice. What do you think? Y equals x plus 2 and x minus 6. Anything else? What about the A? A should go right here at the very front. And we said A was going to be -1/2. So we put -1/2 in here. Very nice job. Good job. You got the hard part. X plus 2, x minus 6. How many got that or something very similar? Nice. And the teacher goes wild. Oh, gosh. Okay. Graphing equations from factored form. Sketch a graph of the given functions. Remember, what looks like the root in our factored form is actually its opposite. So when A says y equals x minus 4 and x plus 3, what are my roots? Guys, everybody get off the phone. Come on, we're almost done here. What is it? Is it 4 or -4? It's +4 and -3. So plot those on the x-axis. 4, 1, 2, 3, 4. and -3. 1, 2, 3. Is this opening up or downward? And how can you tell? How can you tell? Doesn't have a what? Yeah, right up here, this would be your A value. So A is, well, it's not the equals, but it's in front here, like right here. There's nothing there, so it's a 1 understood, right? This would be a 1. And so it has to be opening up because 1 is positive. So we know it's opening up. And 4 and -3, you want it to be symmetric. So it's not quite the y-axis that would be the axis of symmetry, but maybe a little bit something like this. All right. It's not perfect, but it's a pretty good generalization, right? No? Question? Oh. Okay. All right, so let's look at b. Y equals -x plus 2 times x plus 4. Rubble. Morgan? Is that your name? Morgan. What are my roots for b? What would you think? -2 and -4? Is that what you said? What do you guys think about that? Good answer. Family Feud. I always like that. Good answer. Yes. And is it opening up or down? Down. So plot -2 and -4. It's opening downward. Now, you might have put something way up here, but what is my A value here? What is my A value? It is -1. It is negative, and since there's nothing there, it is a -1, so it probably is pretty close to here. But nonetheless, if you give me something that's opening downward and has the roots at -2 and -4, we're good. Okay? Any questions there? Dun, 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 dun. We are done with the notes. How about that? So, for the rest of the time period, since you have homework 12.4 due on Monday, I would strongly recommend that you get started and be working on it. That way, if you have questions, I can walk around and help you. Because I know how it is. You'll not do it now, and then you'll get Friday night. Maybe I'll do it later, and then it's Friday night, and you're tired, and then Saturday comes, and your mom says you got to clean your room, take out the trash, all this stuff, and then Sunday you sleep in, something like that, and then your Sunday night you're like, oh, I'm so tired. But do it, get it done now, and then you'll have it done. Okay? Just do it. Be like Nike. Just do it. All right. Good show, guys. Good show. Good job.